Good morning, dear students and all the viewers. It's me, Indramani Gewali, Math Facilitator. So today, let me recall the previous class. In previous class, I discussed about cardinality relation of union of three different sets, and before that, we discussed some word problems based on two subsets, and we practiced some of the examples on different types, and then we moved into the next topic, cardinality relation of union of three sets. So let me recall about the previous class, which is based on cardinality relation of union of three sets. So today, in the beginning of the class, let's focus on the Venn diagram on the screen. So let's look at the Venn diagram. In a universal set U, there are 8 different regions and which are indicated by different set notations. So the most important part is this is the common region, this is the intersecting region of all three sets A, B and C. So it is called N of A intersection B intersection C. Similarly, this region is the common region of set A and B only. But this region does not belong to set C, so its set notation is N only A intersection B. Similarly, we can see on the diagram there are different set notations which I have mentioned in the diagram. So this one is N only A intersection C because this region is the common region of only set A and C, but this is not the region of set B. So we have to write N only A intersection C. Similarly, if we look at this region, this is the common region of set B and C only, but this region does not belong to set A. Lastly, let's see on what is the set notation for this region. This region, we can see here, this region belongs to set A only, and we write N only A. Similarly, this one is N only B, and this is N only C, and the region which lies outside of set A, B and C, this is called complement, and we denote this by N of A union B union C complement. So looking at this diagram, or from this diagram, we can write some of the important points, some of the formulas we can derive, which we will use in the exercise or for the different questions that we will discuss. So let me begin from what is N of A union B union C. So under N of A union B union C, we can see in the diagram there are 7 different regions which are represented by different set notations. This one is the first, second, third, fourth, fifth, sixth and seventh. There are total 8 different regions in a universal set, but the complement, this does not belong to N of A union B union C. So what are the different regions contained by N of A union B union C? So these different regions are, this one is N only A, this is N only A intersection B and so on. So there are total 7 different regions which we can represent by different set notations. First is N only A plus, what is the next? This one is N only A intersection B plus, what is next? N only A intersection C. So N only A intersection C plus, this is intersection of all three subsets A intersection B intersection C plus, this one is N only B plus, this is N only C, and next is N A intersection. Okay, so this is already mentioned here. Let's see which one is missing. N only A N only A intersection B, N only A intersection C, intersection of all three subsets, N only B, N only C, and next one is N only B intersection C. N only B intersection C. Here should be total 7 different set notations. 1, 2, 3, 4, 5, 6, 7. So from this relation, we can derive a formula for N of A union B union C. So let me talk about what is N only A and how can we find the cardinal number for N only A if we have different informations like N of A, N only A intersection B, intersection of all three subsets, and N only A intersection C. Let me talk about now only N only A. So N only A. So this shaded region in the circle of A, this is N only A. So if we deduct 1, 2, 3, if we deduct these three different regions, region number 1, region number 2, and region number 3, if we deduct these three different numbers, region number 1, 2, and 3 from whole N of A, we can obtain N only A. So this is N of A minus, let's subtract this one, N only A intersection B minus, this is intersection of N A intersection B intersection C minus the last one is N only A intersection C. In this way, we can find N only A. So while inserting the numbers in a Venn diagram, first of all, we fill up the common region, that is intersecting region of all three subsets, and we say N A intersection B intersection C, and then we prefer to insert the number either in N only A intersection B, this region, or in N only B intersection C, or in N only A intersection C. So let me repeat it again. If we are asked to insert the different numbers in a diagram based on three different subsets, first of all, we start inserting the number from the common region. Common region, this is number 2 region in a diagram. Then after, we insert the number either in N only A intersection B, this region, or in N only A intersection C, or N only B intersection C. So we will practice one question today. If possible, we will try to practice 2 questions. Okay, so from this relation, after getting the concept of how to find N only A, using the similar formula for N only A, N only B, and N only C, we can derive a such formula that we can use in different example or different questions. So basically, in 3 subsets, we can solve questions in 2 different ways, that is same as 2 sets. One way is we can use the formula, second we can use Venn diagram method. That is our choice. If we are asked to use Venn diagram method, we need to use Venn diagram, otherwise it depends on us. Either formula method or Venn diagram method can be used. Okay, so let me write a formula. N of A union B union C is N of A plus N of B plus N of C minus N of A intersection B minus N of B intersection C minus N of C intersection A plus we add N of A intersection B intersection C. So this formula can be derived with the help of this, the first formula, N of A union B union C. So this is derived from this one. So if we Write the formula of n only A, n only B, n only C, and if we cancel positive and negative terms, we will obtain this formula. So it can be used in the exercise. Let me take one question or example, and then we will discuss what are the other possible questions in three subsets. Before that, we also can write formula number 3 if we are asked to find the complement. How can we find the complement? It's known n of A union B union C is n of U minus n of A union B union C complement is n of U minus n of A union B union C. If we know the cardinal number of universal n of U and cardinal number of A union B union C, then we can easily find what is n of A union B union C complement. So let me take one example. We can see the question on the screen. Let's read the question and write down the information which are mentioned in the question. Let me read out what is the first example. Example number 1. Example number 1, let me take example first, and now I'm reading the question. You can see the question on the screen. A survey of a group of students showed that in a survey of a group of students showed that 60 liked tea, 45 liked coffee, 30 liked milk, 25 liked coffee as well as tea, 20 liked tea as well as milk, 15 liked coffee as well as milk, and 10 liked all three. If every student liked at least one drink, there are two questions asked. How many students were asked this question? Means what is the total number of students participated in a survey? Second is how many students liked exactly 2 drinks. So this is a key point, exactly 2 drinks. We will discuss this. So first of all, question talks about 3 different items, 3 different drinks which are mentioned in the question: tea, coffee and milk. So let T, C and M denote the set of students who liked tea, coffee and milk respectively. Now let's write the information which are given in question. Here we are asked to find the total number of students. So n of U is asked, that is unknown. So 60 liked T, so n of T is 60. N of C we are given, n of C is 45. What is n of M? N of M is 30. Now let's write the information that are common. 25 liked coffee as well as tea. So n of coffee as well as its intersection C intersection T is 25. 20 liked tea as well as milk. N of tea as well as milk is 20. 15 liked coffee and milk. N of coffee and milk is 15, and 10 liked all three. N of T intersection C intersection M is 10. So these are the information provided in question. So with the help of all this information, now we can draw a diagram. We can fill up all these numbers in a diagram and find how many students were asked this question. Here is a one sentence, the last sentence. If every student liked at least one drink, its meaning is, out of 3 different items, tea, coffee and milk, if every student liked at least one drink, there is no one who do not like any of the drinks. That means there is no complement at all. That is the meaning of the last part, last sentence. Let's draw a diagram. Let's draw a Venn diagram. And we will insert these numbers in a Venn diagram. We will insert in Venn diagram. This question is based on 3 subsets. So we will draw 3 subsets in a diagram. Let's write, first is T, C and M. Okay. So now how to start filling the diagram? This is the main concept. So in case of 2 subsets, it's similar. We fill the common region of 2 sets. Similarly, here in case of 3 different subsets, we start inserting the number in the middle region, the intersecting region, which is common region of all 3 sets here, T, C and M. So what is the intersection of all 3 subsets? This is 10. So let's put 10 in the common region. Similarly, after this, we insert the number in either this region. This is called N only T intersection C. In the second step, after inserting the number in the common region, in the second step, we insert number either in this region or in this one or in N only T intersection M. But I think I need to again discuss how to insert a number. How to insert a number, or what is the number to be inserted in this region and only T intersection C. So what is and only T intersection C? How to find and only T intersection C? What is the number to be inserted here in the shaded part, in the shaded region? So we have T intersection C. T intersection C is 25. T intersection C is 25, but T intersection C include 2 different regions in a diagram. So these 2 regions are, we can say this is the common region. This is the common region of T and C. But 10 is already inserted. So if we deduct 10 from 25, we can obtain the number to be inserted in T intersection C only. So N only T intersection C is N of T intersection C, N of T intersection C minus intersection of all 3 subsets, intersection of all 3 subsets. So let me write over here the hint, N only T intersection C. This is N of T intersection C minus N T intersection C intersection M. So 25 minus 10 is, it should be 15. This is 15. Similarly, now let's fill up this one, intersection of C and M only. So what is C intersection M? C intersection M is 15. So out of 15, 10 is already inserted in the common region of three different subsets. So for this region, we need to subtract 10 from 15 and we get 10 minus 15 is 5. Now let's move into next region. This is common region of T and M only. So what is the cardinal number for this? T and M. Let's look at what is T intersection M, 20. So if we deduct 10 from 20, we get the number for this region. So 20 minus 10 is 10. Okay. Now we can see we have filled the numbers in 4 different regions, 1, 2, 3, 4. Now we need to fill the numbers in annually T, annually C and annually M. Now what is annually T? So look at the hint. What is annually T? How can we find the number for annually T? So n only T is equal to n of T minus n of T minus n of T minus 15 minus 10 minus 10. So n of T minus n only T intersection C minus n of T intersection M intersection C minus n only T intersection M. Or in short, what we can understand is for n only T, let's add the numbers 15 plus 10 plus 10. So what is 15 plus 10 plus 10? 20 plus 15 is 35. So what is n of T? 60. So if we deduct sum of these three numbers from 60, we obtain the number for annually T, and that is 60 minus 35 is 25. Similarly, for annually C, what is annually C? For annually C, let's add again the numbers which are inserted in the circle of C. 15 plus 5 is 20 plus 10 is 30. What is n of C? 45. So 45 minus 30 is 15. Now one is left, n only M. For n only M, what are the numbers which we have inserted in set M? 10 plus 10, 20 plus 5 is 25. So if we deduct 25 from n of M, which is 30, we can obtain the number for n only M. So 30 minus 10 minus 10 minus 5 is 5. So this is the way how we fill Venn diagram based on 3 different subsets in a universal set U. Let's solve first question now. Here in number A, how many students were asked this question? That is n of U. Here n of U is the total number of students who were asked the question. So if we add the number which we have filled in a diagram, like 25 plus 15 plus 15 plus 10 plus 5 plus 10 plus 5, we will obtain n of U. So n of U is simply 25. Let's add the numbers plus 15 plus 15. That's all the numbers which are in either set T or in C or in M. Plus 10 plus 10 plus 5 plus 5. Or this is simply n only T plus n only T intersection C plus n only C plus intersection of all 3 subsets plus n only T intersection M plus n only C intersection M plus n only M. So let's add this. Okay, so 25 plus 15 is 40, 50, 60, 70 plus 15 is, this is 85. So there were 85 students in a survey. Now B number, let me erase and write on the top. So with the help of Venn diagram, Now what is question number B? How many students liked exactly 2 drinks? How many students liked exactly 2 drinks? For this, from the Venn diagram, let's try to identify what are the different reasons where the students liked exactly 2 drinks. So these 2 reasons, there are 3 different reasons, which are this reason here. This 15 is the number of students who exactly like tea and coffee, that is and only T intersection C. Let me give you a concept. So number of elements in exactly 2 sets is and only T intersection C plus and only T intersection M plus and only, what is the next one, C intersection M. So and only T intersection C, its meaning is the number of elements which lies exactly in T and C. Similarly, there are 2 other different set notations. So for question number B, how many students liked exactly 2 drinks? So the number of students who liked exactly 2 drinks is equal to, we can add and only T intersection C plus and only T intersection M plus and only C intersection M. So what is and only T intersection C? T intersection C only is 15 plus what is and only T intersection M? T intersection M only is 10 plus what is and only C intersection M? It's 5. So this is 15 plus 5, 20 plus 5 is 30. So this is the way how we fill a Venn diagram, and with the help of Venn diagram we can solve the questions. Whatever the question asks for us, we can solve by using Venn diagram after inserting the different numbers in a diagram. So here, if we are asked to find, let me add one more question here. If we are asked to find how many students liked exactly 1 drink, exactly 1 is 25 plus 15 plus 5. Okay, so thank you all for being with me. So we also can watch the video in YouTube channel of Janata Television. If you are missing this class, thank you all. Stay safe.